Hello, this is Emma Lanto from Period 7 Honors PreCalc, and today I'm helping you calculate the arc length if you're given a central angle in radians. So, some given information that you would have is you'd be given a circle most likely, and be given theta, which is the given central angle in radians, of course, and then r would be the radius of the given circle, and then s is the unknown variable. Usually, I mean, you could solve for any variable, but s is the most common, and that would be the arc length. And that could be in whatever dimensions it's given in the problem. So, what to use? You would use the formula to find an arc length with the given information. It would be s equals 2 pi r times, parenthesis, theta over 2 pi. And 2 pi, of course, is equivalent to 360 degrees, and that's just the total circumference of a circle in degrees. So it's kind of like, think about it as like a fraction of sorts. You have a certain number of degrees over the full number of degrees in that circle. And so where does this formula come from? Circumference equals pi d, and diameter equals d equals 2r. So of course we get that from 2 pi r is the area of the circumference. So it's like thinking about it as the whole circle and then times like the measure of the whole circumference around the circle, but then times a fraction. So it's not including the whole circle. So you could kind of think about it like that. And so then there's the proportion, and then think of it as a percentage calculation. It's just theta over 2 pi. Again, it's just the degrees and radians over the total degrees in that circle once around, because you could have more than one. You could go around multiple times. Alright, so continuing on. So how do you use this formula? Again, it's s equals 2 pi r, which is, again, the circumference, 2 pi r, times theta over 2 pi. So we're going to apply it to a couple of examples. So this is the first one. Example A is known information as you're given theta, which of course is in radians, so you're given pi over 3, and then the radius is 9 inches. So you're solving for s, which is the arc length, and we're going to solve for s in inches because it gave us the radius in inches, and we're going to just use that as a common unit of sorts. Alright, so there's a picture of it. You could see how it's set up, and it's probably around 60 degrees. I mean, if I didn't know radians, I would say it was about 60 degrees, but I do know radians, so it is 60 degrees. Alright, so then use the equation. S equals 2 pi r times theta over 2 pi to solve for s. So you plug in the known information into that equation. And so you have 2 pi times 9, and then pi over 3 over 2 pi. So we can simplify it, and we get 18 pi times 1/16, and that equals 9.4248 inches. So there you go. It's that easy. Its arc length is 9.4248 inches. And you could solve for any number of, you could solve for r, you could solve for theta, you could solve for s. And so I'll give you a second example in which we solve for theta. And so example B is the known information is the arc length is 31.27 centimeters and the radius is 7 centimeters. So we're going to solve for theta in radians. So you use the equation again. It's s equals 2 pi r times theta over 2 pi. So the first step is just to plug in the known information again like we did the first time. And so we put 31.27 equals 2 pi times 7, which is the radius, times theta over 2 pi. So we simplify that down to 31.27 equals 43.982 times theta over 2 pi. So there we just multiplied the circumference together. So we had the 2 pi r, the 2 pi 7, and that's how we got the 43.982. And so then we're going to divide the 43.982 to the other side. So that cancels on this side right here on the right side. And we're going to divide it over onto 31.27. So you get 0.71429. And of course that equals theta over 2 pi. And so then we're going to multiply 2 pi on either side. So that it'll cancel from the denominator on the right side and then multiply to become 4.488 on the left side. So that is theta. So degrees in radians is 4.488. Alright, so there you go. That is the ending of my presentation. It just, the real life application, it could be applied to anything. If you're like garden work, construction, building, anything involving a circle, and you just need the length of a certain area, whether it's for fencing or windows or anything like that. Or it could just be in class, but I mean, it is a pretty useful tool, and there you go. So have fun and enjoy.